What if we're not alone? Out there, beyond the familiar glow of our own solar system, worlds unlike anything we've ever known orbit distant stars, some bathed in perpetual twilight, others scorched by twin suns, and a few, just maybe, cradling the whispered secrets of life itself. For centuries, we've gazed at the stars and wondered, are we the only ones? But today, that question isn't just the stuff of dreams or science fiction. Thanks to revolutionary discoveries, we now know of thousands of exoplanets, alien worlds circling far-off suns, and among them, hidden in the cosmic haystack, are a handful with the tantalizing potential to host life. Imagine standing on the surface of one of these distant worlds. The sky might blaze with unfamiliar constellations, the air thick with gases we'd find poisonous, or maybe, just maybe, with the faintest traces of something far more extraordinary. Scientists call these places habitable, not because they're cozy vacation spots, but because they meet the Goldilocks conditions. Not too hot, not too cold, with the right chemistry and just enough starlight to keep water liquid. And where there's water, there's hope. From the crushing depths of ocean-covered super-Earths to the thin, icy shells of moons orbiting gas giants, the universe is teeming with possibilities, each one a clue in the greatest detective story of all time, the search for our cosmic neighbors. In this journey, we'll explore 30 of the most promising candidates' worlds where the ingredients for life might already be mixing, where alien microbes could be thriving, or where, perhaps, intelligence unlike our own is looking right back at us across the void. Some are rocky like Earth, others shrouded in eternal storms, and a few defy everything we thought we knew about where life can exist, so buckle up. We're about to venture far beyond our solar system, to places where the line between science and imagination blurs, and where every discovery brings us one step closer to answering humanity's oldest question: are we truly alone in the universe? The answer might be waiting on one of these extraordinary worlds. Among the countless worlds drifting through the cosmos, one stands out as a milestone in our search for life beyond Earth, Kepler 186f. Discovered in 2014, this distant planet was the first Earth-sized world confirmed to orbit within the habitable zone of its star, a region where temperatures could allow liquid water to pool on its surface. Picture our own planet suspended in that delicate balance between freezing and boiling. Now imagine a world 500 light-years away, basking in the dim, reddish glow of its sun, Kepler 186, a star cooler and smaller than our own. The light there would feel strange to our eyes, more like a perpetual sunset, but beneath that alien sky, rivers or even seas might carve their way across the landscape. What makes Kepler 186f so extraordinary isn't just its size, only 10% larger than Earth, but its orbit. A year there lasts just 130 Earth days, snug in that Goldilocks sweet spot where water could cling to the surface. Scientists can't yet confirm if it has an atmosphere or oceans, but the mere possibility rewrote the rules of the cosmic hunt. Before its discovery, we'd found gas giants and scorched, rocky worlds, but here was proof that planets like ours weren't just possible, they were waiting to be found. The challenges, though, are as fascinating as the potential. Kepler 186f is tidally locked, meaning one side forever faces its star while the other lingers in darkness. Yet life, if it exists there, might thrive in the twilight border between these extremes where temperatures could be just right. Think of Earth's hardiest organisms clinging to volcanic vents or frozen tundras. Now stretch that ingenuity across an entire world. Could photosynthesis evolve under a crimson sun? Could an atmosphere trap enough heat to nurture life? Every unanswered question about Kepler 186f reminds us that the universe delights in defying expectations. This world's discovery didn't just add another pin to the galactic map, it ignited a new era. For the first time, we had proof that Earth wasn't a cosmic fluke. If a planet this familiar could exist around a star so different from our Sun, what else might be out there? Kepler 186f isn't just a candidate for alien life, it's a beacon, urging us to look deeper, to question broader, and to wonder if, somewhere in that distant twilight, another civilization might be gazing back at us, just as curious, just as hopeful. Just 4.24 light-years away, practically next door in cosmic terms, lies Proxima Centauri b, the closest known exoplanet to Earth and one of the most tantalizing places we might find signs of life beyond our solar system. Orbiting the faint red dwarf Proxima Centauri, this rocky world is a study in extremes. Its star is so dim that even at such a close distance, the planet receives only about 65% of the energy Earth gets from the Sun. But here's the catch: Proxima Centauri b is so near its star that a full orbit takes just 11 Earth days, placing it firmly in the habitable zone where liquid water could exist. The surface of this world would be unlike anything we've ever seen. Tidal forces have locked it in place, meaning one side is perpetually bathed in weak, reddish light while the other is frozen in eternal night. Yet between these two extremes lies a narrow ribbon of twilight, the Terminator Zone, where temperatures might be just right for liquid water to flow. Imagine standing in that twilight belt where the sun never rises or sets, hanging motionless in the sky like a dull ember. The landscape might be a patchwork of scorched rock and icy plains, but where these zones meet, rivers could carve through valleys, or lakes might shimmer under a perpetual dusk. But Proxima Centauri b isn't just a place of quiet beauty, it's a battleground. Its star, a red dwarf, is prone to violent flares that bombard the planet with deadly radiation. Without a thick atmosphere or a strong magnetic field, life on the surface could face constant bombardment. Yet beneath an ocean or beneath layers of ice, microbes might find shelter, much like the extremophiles near Earth's volcanic vents. Some scientists even speculate that the flares could trigger chemical reactions in the atmosphere, creating biosignatures we might detect from Earth. The hunt for answers is already underway. Projects like Breakthrough Starshot aim to send tiny probes hurtling toward this system within decades, while next-generation telescopes could one day analyze its atmosphere for signs of oxygen or methane. If life does cling to this world, we might be the generation to find it. Proxima Centauri b isn't just another exoplanet. It's a test of our boldest ideas about where life can endure, and a reminder that the universe keeps its greatest secrets closer than we think. TRAPPIST-1e isn't just another exoplanet, it's a cosmic jackpot. Nestled in the TRAPPIST-1 system 39 light-years away, this world is one of 7 Earth-sized planets orbiting an ultra-cool dwarf star, a discovery so groundbreaking it rewrote what we thought possible for planetary systems. Picture this, a star so faint and small that if you stood on TRAPPIST-1e's surface, its light would feel more like a warm, dim glow than the blazing sun we know. Yet in that gentle radiance, conditions might be just right for life to take hold. What makes this planet so special? For starters, it's smack in the middle of its star's habitable zone, with a year that lasts just 6 Earth days. Its orbit is so close that if you replaced our Sun with TRAPPIST-1, this planet would fit comfortably inside Mercury's path. But here's the twist: despite the tight dance, the star's cool temperament means TRAPPIST-1e could avoid the scorching fate of Mercury. Instead, temperatures might allow liquid water to exist if it has the right atmosphere, and that's the big mystery. Scientists believe this world is rocky, possibly with iron-rich soil and towering mountain ranges. But does it have air, clouds, rain? Observations suggest it could hold onto an atmosphere thick enough to distribute heat, shielding potential oceans from freezing over. Imagine a landscape where the sky is a perpetual dusky orange, the horizon lit by the silhouettes of its sister planets, some appearing larger than our moon. NASA has its sights locked on this system. The James Webb Space Telescope has already studied TRAPPIST-1e's atmosphere for hints of carbon dioxide or water vapor, clues that could point to active geology or even life. The planet's compact orbit also means future telescopes might catch weather patterns or surface changes over just weeks. Yet challenges loom. Red dwarfs like TRAPPIST-1 are notorious for violent flares, and without a strong magnetic field, this world could be stripped bare over time. But life, if it's there, might find refuge underground or in deep oceans, thriving in ways we've yet to imagine. TRAPPIST-1e isn't just a scientific target. It's a test of how creative and resilient life can be in the universe's quietest corners. LHS-1140b isn't just another world, it's a heavyweight contender in the search for alien life. This super-Earth, nearly 7 times more massive than our planet, orbits a quiet red dwarf star 49 light-years away, and what makes it extraordinary isn't just its size, but its potential to cradle life in the most unexpected ways. Unlike many exoplanets around volatile red dwarfs, this one hit the cosmic jackpot with a star that's remarkably calm, offering a rare stable environment where life could have the time and conditions to emerge. Imagine standing on the surface of LHS-1140b. The gravity would feel crushing, nearly 3 times stronger than Earth's, pressing down on vast rocky plains or perhaps even sprawling ice sheets. But beneath that weight, something incredible might be hiding. Scientists believe this planet could have a dense, thick atmosphere, acting like a cosmic pressure cooker that traps heat and keeps water liquid despite the faint glow of its star. Unlike the violent flares of Proxima Centauri, the gentle nature of LHS-1140 means its atmosphere might have survived billions of years, creating a protective blanket that could even fuel rain cycles or vast subsurface oceans. The star's stability is the real game-changer here. Many red dwarfs unleash deadly radiation flares that strip away atmospheres, but LHS-1140's star is a rarity, older, quieter, and far less destructive. That stability boosts the chances that this planet didn't just start with the right ingredients for life, but kept them. Telescopes have already detected hints that it could be a water world, with a global ocean lurking beneath a thick, steamy atmosphere or a frozen shell. If true, it would mirror the icy moons of Jupiter and Saturn, where hidden oceans teem with potential for microbial life. Future telescopes like the James Webb Space Telescope are itching to take a closer look. By analyzing starlight filtering through LHS-1140b's atmosphere, scientists hope to spot telltale signs of water vapor, methane, or even oxygen, a cocktail of gases that could hint at biological activity. But the real excitement lies in the unknown. Could an ocean under miles of ice host alien ecosystems? Could a thick atmosphere nurture surface life adapted to the crushing gravity? Every new observation peels back another layer of this enigmatic world, reminding us that the universe's most promising havens for life might not look like Earth at all, but something far stranger. LHS-1140b doesn't just challenge our assumptions about where life can thrive. It dares us to rethink what life might even look like under alien skies. Kepler 442b isn't just another Earth-sized exoplanet, it's one of the most Earth-like worlds we've ever discovered, a cosmic mirror reflecting conditions eerily familiar to our own. Orbiting a star over 1,000 light-years away, this rocky planet sits snugly in its habitable zone, receiving just enough sunlight to keep water liquid without boiling it away. If you could stand on its surface, the sky might not look so different from ours, a sun slightly cooler and redder than Earth's, casting a golden hue over landscapes that could, in theory, cradle rivers, forests, or even life itself. What sets Kepler 442b apart is the delicate balance of its conditions. While it's about 1/3 larger than Earth, its gravity would feel only slightly stronger, making it one of the few worlds where humans could theoretically walk without being crushed by their own weight. But the real magic lies in the sunlight it receives, around 70% of what Earth gets from our sun. That's enough to keep temperatures in a range where liquid water could pool on the surface, much like the mild climates of our own planet's temperate zones. The star it orbits, Kepler 442, is another piece of the puzzle. Unlike our Sun, which will eventually swell into a red giant and scorch the inner solar system, this star is a K-type dwarf, smaller, cooler, and far more patient. These stars burn their fuel slowly, living for tens of billions of years, compared to our Sun's mere 10 billion. For life, that's an eternity of stability. Imagine a planet where evolution isn't racing against a ticking clock, where civilizations could rise and fall across spans of time that dwarf human history. Yet challenges linger. Kepler 442b's orbit is tighter than Earth's, with a year lasting just over 100 Earth days. That proximity could mean tidal locking, where one side of the planet always faces its star, creating extremes of heat and cold. But life, if it exists, might thrive in the twilight zones between these regions where temperatures could be just right. Or perhaps it's hidden beneath an ocean, sheltered from stellar flares or atmospheric thinning. Scientists are particularly intrigued by this world's potential for photosynthesis. With starlight similar to Earth's, alien plants, or something even stranger, might have evolved to harness that energy, painting the landscape in colors we can't yet imagine. Future telescopes could analyze the chemistry of its atmosphere for signs of oxygen or methane, fingerprints of biological activity. Kepler 442b isn't just a candidate for life, it's a glimpse into a parallel Earth, a reminder that the ingredients for habitability might be common in the cosmos. Its existence suggests that planets like ours aren't rare accidents, but part of a vast galactic tapestry, each thread a potential home for something, or someone looking back at the stars and wondering just as we do. K2-18b shatters every assumption we've ever made about where life could exist. This mysterious world, orbiting a red dwarf star 110 light-years away, isn't just another exoplanet. It's a Hycean world, a term scientists coined to describe planets with hydrogen-rich atmospheres and vast global oceans. Picture an Earth-sized planet swallowed by an endless sea, its skies thick with hydrogen and helium where the air pressure at the surface could crush a submarine. Yet beneath those crushing depths, something astonishing might be stirring. What makes K2-18b so groundbreaking is the discovery of water vapor in its atmosphere, a first for any exoplanet in the habitable zone. Telescopes like Hubble caught the telltale fingerprints of H2O, hinting at a world where water isn't just frozen or vaporized but pooled in liquid form. But here's the twist, this isn't an ocean world like Earth. Hycean planets are a whole new category, where oceans might stretch thousands of miles deep under skies filled with hydrogen, creating pressures and chemistries unlike anything we've seen. The debates among scientists are as turbulent as K2-18b's hypothetical seas. Some argue the planet's thick hydrogen blanket could act like a cosmic pressure cooker, trapping enough heat to keep water liquid even far from its star. Others warn that without a rocky surface, life would have to thrive entirely in the water column, perhaps near hydrothermal vents where chemistry could spark biological activity. Then there's the wild card. Hydrogen atmospheres can produce organic molecules like ammonia and methane, building blocks for life under the right conditions. Could alien microbes be floating in those alien oceans, feeding on chemical energy from the depths? But challenges loom. Red dwarfs like K2-18b's star are notorious for violent flares, and without a magnetic field, the planet's atmosphere might be slowly stripped away. Yet life, if it exists, might have found refuge in the darkest depths, where the ocean itself acts as a shield. The upcoming James Webb Space Telescope could settle some of these debates, probing the atmosphere for signs of dimethyl sulfide, a gas on Earth produced only by living organisms. K2-18b forces us to rethink the very definition of habitable. It's not a planet where humans could ever walk, but it might be a universe where life doesn't need a rocky shore or a breathable sky. just an endless, churning sea beneath a smothering hydrogen veil. If life thrives here, it would prove the cosmos is far more inventive than we ever dreamed. GJ357d isn't just another exoplanet. It's a cosmic paradox, a world where the potential for life collides with the harsh realities of an alien sun. Discovered by NASA test mission in 2019, this super-Earth orbits a dim, cool M-dwarf star just 31 light-years away, close enough to make it one of our best shots at studying a habitable zone planet up close. At 6 times the mass of Earth, GJ357d straddles the line between rocky giant and miniature Neptune, leaving scientists debating what its surface might look like. Could it be a sprawling, mountainous world with towering cliffs and deep valleys, or a waterlogged sphere shrouded in global oceans? What makes this planet so compelling is its orbit, a chilly, slow dance around a star that gives off just a fraction of our sun's warmth. A year here lasts roughly 55 Earth days, but GJ357d isn't scorched like Mercury. Instead, its distant, dim star places it squarely in the habitable zone, where temperatures could allow liquid water to exist if it has the right atmospheric blanket. Imagine standing on this world's surface. The sky would be a perpetual dusk, the sun a faint, ruby disk casting weak shadows. But beneath that eerie glow, rivers might snake through valleys, or ice caps could melt into shallow seas at the equator. The challenges, though, are as stark as the possibilities. M-dwarf stars like GJ357ds are notorious for their tempers, frequently erupting in violent flares that bathe nearby planets in deadly radiation. Without a robust magnetic field or a thick atmosphere, this world could be stripped barren over time. Yet there's hope. Some models suggest GJ357d might have a dense carbon dioxide atmosphere, acting like an insulating cocoon to trap heat and shield the surface. If true, its environment could resemble a high-pressure greenhouse, where microbial life might cling to hydrothermal vents or thrive in subterranean aquifers. NASA James Webb Space Telescope has this planet in its sights, ready to probe its atmosphere for signs of water vapor or methane clues that could rewrite our understanding of habitability. GJ357d forces us to ask, does life need a sun like ours, or can it persist in the dim, flickering light of a red dwarf? Whether this world is a frozen wasteland or a hidden oasis, it's a reminder that the universe's most promising real estate might not look anything like home. TOI 700d isn't just another exoplanet, it's a rare gem in the cosmic hunt for life, a world that ticks nearly every box on the checklist for habitability. Discovered by NASA test mission in 2020, this Earth-sized planet orbits a small, cool M-dwarf star just over 100 light-years away. And what makes it extraordinary isn't just its size, but its place in the habitable zone. Unlike the chaotic orbits of many exoplanets, TOI 700d's path around its star is almost poetic in its precision, receiving just 86% of the solar energy Earth gets from our sun, enough to keep water liquid without boiling it away. Standing on its surface would feel alien yet eerily familiar. The planet is tidally locked, meaning one side perpetually faces its star while the other is locked in eternal night. But instead of a barren wasteland, scientists speculate this world could host a climate unlike anything in our solar system. The day side might bask in a perpetual golden twilight, with temperatures hovering near 20 degrees Celsius, perfect for liquid water. Meanwhile, the night side could be a frozen expanse, but between these extremes, a belt of temperate twilight might stretch like a narrow oasis, where air currents could distribute heat and moisture, creating stable conditions for life to emerge. The star it orbits, TOI 700, is another stroke of cosmic luck. Most M-dwarfs are volatile, prone to violent flares that strip away atmospheres, but this star is unusually calm, giving TOI 700d a fighting chance to retain its air and water over billions of years. Models suggest the planet could have a thick carbon dioxide atmosphere, acting like a thermal blanket to trap heat and prevent its oceans from freezing. Even more tantalizing, its climate might resemble Earth's early days, with shallow seas and hazy skies, a stage where chemistry could have already sparked biology. NASA James Webb Space Telescope has this world in its crosshairs, ready to analyze its atmosphere for signs of water vapor, methane, or even oxygen. But the real intrigue lies in the unknowns. Could photosynthesis evolve under a dim, red sun? Could life huddle in the Terminator zone where day and night meet? TOI 700D doesn't just challenge our assumptions about habitable worlds. It offers a masterclass in cosmic patience, proving that even in the quietest corners of the galaxy, the right conditions can whisper the promise of life. Kepler-62f isn't just another exoplanet, it's a time capsule from an ancient cosmos, a world that's had billions of years to brew the chemistry of life. Orbiting a star strikingly similar to our own Sun, this distant planet sits 1,200 light-years away in the constellation Lyra, basking in the gentle glow of a G-type star almost identical in size and temperature to the one that lights our skies. But what truly sets Kepler-62f apart is its place in the habitable zone, a region where liquid water could exist not just temporarily but for epochs. With an orbit lasting 267 Earth days, this world receives just enough starlight to keep its potential oceans from freezing or boiling away. A Goldilocks balance that's endured for an astonishing 7 billion years, 3 billion years longer than Earth has even existed. Size matters when it comes to habitability, and Kepler-62f pushes the limits. At 1.4 times the diameter of Earth, it falls into the category of super-Earth, a type of planet our solar system mysteriously lacks. The extra volume could mean towering mountain ranges and deep oceanic trenches, but it also raises questions. Is this a rocky world with continents, or a waterlogged sphere where land is a rarity? Some models suggest it could be a true water world, with a global ocean hundreds of miles deep beneath a thick, steamy atmosphere. Imagine standing on the shore of such a planet, if shores exist at all. The horizon might stretch uninterrupted, a boundless expanse of waves under a pale yellow sun, with no islands or coastlines in sight. Yet even in such extremes, life could flourish around hydrothermal vents or in the planet's hypothetical ice-covered poles, where temperatures might allow for pockets of liquid water. What makes this world a standout candidate isn't just its present conditions, but its past. 7 billion years is more than enough time for life to arise, evolve, and potentially even reach complexity. While Earth's biosphere was still in its infancy, Kepler-62f might have already been a mature world, its oceans teeming with primordial organisms. The star's stability is another boon. Unlike the volatile red dwarfs that torment many exoplanets, this sun-like star offers a steady, predictable rhythm of light and warmth. Yet mysteries linger. Telescopes haven't yet detected an atmosphere around Kepler-62f, leaving scientists to wonder, does it have the right mix of gases to nurture life? Could plate tectonics, a critical recycling mechanism for Earth's climate, even happen on a planet this size? Future observatories like the Habitable Worlds Observatory may finally answer these questions, searching for the faint glint of starlight filtering through alien air. Until then, Kepler-62f remains a tantalizing what-if, a reminder that the universe had a head start on crafting life, and that some of its oldest experiments might still be out there waiting to be found. Wolf 1061c is the cosmic neighbor you've never heard of, a rocky world just 14 light-years away, so close that in galactic terms it's practically waving at us from across the street. Orbiting the red dwarf star Wolf 1061, this exoplanet is one of the most intriguing candidates for habitability we've found in our immediate stellar neighborhood. But don't let its proximity fool you. This isn't some peaceful Earth twin. Wolf 1061c is a world of extremes caught in a gravitational tug of war between promise and peril. What makes this planet so compelling is its position snug in the habitable zone, where temperatures could allow liquid water to exist, but habitable here doesn't mean comfortable. Wolf 1061c orbits its star every 18 days, so close that tidal forces have likely locked one side in perpetual daylight and the other in endless night. The terminator line between these two realms could be the only place where conditions are temperate enough for life, a narrow strip of twilight where water might pool and clouds could form. Picture standing in that eternal dusk, the sky dominated by a dull, crimson sun, its light too weak to burn but just strong enough to sustain. Yet the real challenge comes from the star itself. Red dwarfs like Wolf 1061 are notoriously moody, prone to violent flares that can erupt without warning, bombarding nearby planets with lethal radiation. Without a robust magnetic field or a thick atmosphere, Wolf 1061c's surface could be a scorched wasteland, stripped bare by stellar tantrums over billions of years. But here's the twist: life might not need a friendly surface to survive. If this planet has held onto its atmosphere, or better yet, if it hosts subterranean oceans, microbes could thrive in the darkness, shielded from the chaos above. Imagine extremophiles huddled around thermal vents, their existence untouched by the storms raging in the sky. Scientists are particularly intrigued by the planet's mass, around 4 times that of Earth. That extra heft suggests a rocky composition, possibly with active geology that could recycle nutrients and regulate climate. But it also means gravity would feel crushingly intense, making the idea of walking there a fantasy. Future telescopes might one day analyze Wolf 1061c's atmosphere for biosignatures, searching for traces of oxygen or methane that could hint at biological activity. For now, it remains a tantalizing mystery, a world close enough to study in detail but alien enough to defy expectations. Wolf 1061c doesn't just challenge our ideas about habitability, it forces us to rethink survival itself. In the quiet hum of a red dwarf's glow, life might cling to existence in ways we're only beginning to imagine, proving that the universe's most resilient tenants don't need paradise. Just a chance. Kepler 452b isn't just another exoplanet, it's the closest thing we've found to Earth's long-lost twin. Orbiting a star eerily similar to our own Sun, this distant world sits 1,400 light-years away in the constellation Cygnus, and its resemblance to our home planet is so uncanny that scientists have dubbed it Earth's cousin. The numbers alone are staggering. Its orbit lasts 385 Earth days, just 20 days longer than ours, and it receives only 10% more sunlight, close enough to place it squarely in the habitable zone. But what truly sets Kepler 452b apart is the star it circles. Unlike the red dwarfs that dominate the exoplanet catalogue, this star is a G-type yellow dwarf, nearly identical in size and temperature to our Sun, and it's been burning steadily for 6 billion years. That's 1 billion years longer than our Sun has existed, meaning this star and its planet have had an unimaginable head start on the recipe for life. Standing on Kepler 452b's surface, the sky might look hauntingly familiar. The Sun would glow with the same golden hue we know, casting shadows at angles that wouldn't feel out of place on Earth. But the planet itself is slightly larger, 60% bigger than Earth, giving it stronger gravity and possibly towering mountain ranges or vast, shallow seas. Scientists suspect it's rocky, with active geology that could recycle nutrients and regulate climate, much like Earth's tectonic plates. The real magic, though, lies in its longevity. 6 billion years is more than enough time for life to arise, evolve, and potentially even reach complexity. While Earth's earliest microbes were just beginning to experiment with photosynthesis, Kepler 452b might have already been a thriving world, its oceans teeming with ancient organisms. Yet for all its promise, this planet isn't without challenges. Its extra size means gravity would feel crushingly intense, making every step a labor. And while its star is stable now, it's older than our Sun, inching toward the end of its lifespan. In another billion years, it will begin expanding into a red giant, eventually engulfing Kepler 452b in a fiery finale. But for now, it remains a beacon of possibility. Telescopes have yet to confirm an atmosphere, but if it possesses one with the right mix of gases, oxygen, carbon dioxide, water vapor, it could be the most Earth-like world we've ever discovered. The discovery of Kepler 452b didn't just add another pin to the galactic map. It rewrote the rules. Before its detection in 2015, we weren't sure planets like ours could exist around stars so similar to the Sun. Now we know they do, and that realization changes everything. If a world this familiar exists in the cosmos, how many others are waiting to be found? Kepler 452b isn't just a candidate for alien life. It's a mirror held up to our own planet, a reminder that Earth might not be the exception, but part of a much larger cosmic family. HD 40307g isn't just another super-Earth. It's a cosmic tightrope walker, balancing on the edge of possibility in a way that captivates astronomers. Located 44 light-years away in the constellation Pictor, this hefty world tips the scales at 7 times Earth's mass, orbiting a quiet orange dwarf star with a year that lasts just under 200 Earth days. But what truly sets it apart isn't just its size, it's the way it defies expectations. Most planets this massive are gas-shrouded mini-Neptunes, yet HD 40307g appears to be something far rarer. A colossal rocky world with the potential for a thick, life-nurturing atmosphere. Picture standing on its surface. The gravity would be crushing, nearly twice Earth's, pressing down on sprawling continents or perhaps vast, shallow seas. But the real magic lies in its sky. Unlike the thin, wispy atmospheres of Mars or even the soupy methane haze of Titan, this planet could boast an airy envelope rich in nitrogen and oxygen, dense enough to trap heat without smothering the surface. Its star, HD 40307, is a K-type dwarf, slightly cooler and smaller than our Sun, but with a gentler temperament. That stability is key. While many red dwarfs bombard their planets with deadly flares, this star's steady glow might have given HD 40307g billions of years to cook up the chemistry of life, its atmosphere eroding slowly enough to preserve oceans or even weather systems. Discovered in 2012, this planet wasn't just another addition to the Exoplanet catalog, it was a revelation. Early models suggested it might be a water world, a globe-spanning ocean beneath a steam-filled sky. But newer research hints at something even more intriguing. A mix of land and water, with temperatures that could average a mild 10 degrees Celsius in the right conditions. The secret, its orbit, sitting comfortably in the middle of its star's habitable zone. HD 40307g gets 80% of the sunlight Earth does, enough to keep water liquid without turning the planet into a pressure cooker. Yet mysteries linger. Telescopes haven't yet confirmed the presence of an atmosphere, leaving scientists to wonder, does this world have the right cocktail of gases to sustain life? Could its hefty core generate a magnetic field strong enough to deflect stellar radiation? The answers might lie in future observations. Instruments like the James Webb Space Telescope could analyze starlight filtering through its atmosphere, searching for the fingerprints of water vapor or even methane, a gas that on Earth is often produced by living organisms. HD 40307g isn't just a scientific curiosity, it's a test case for the diversity of habitable worlds. It proves that planets don't need to be Earth-sized to be Earth-like, and that life, if it exists, might thrive in the unlikeliest of places, on a super-Earth where the air is thick, the gravity intense, and the sunsets forever tinged with the orange glow of a quiet, patient star. Kepler 1649c isn't just another world, it's a cosmic resurrection story. Buried in old data from NASA Kepler mission, this Earth-sized planet was overlooked for years before scientists, reanalyzing the numbers in 2020, stumbled upon one of the most promising candidates for alien life we've ever found. Orbiting a dim red dwarf star 300 light-years away, this world is a testament to persistence, both in the hunt for exoplanets and perhaps in the tenacity of life itself. What makes Kepler 1649c so special? For starters, it's almost exactly Earth size, just 1.06 times larger, and it receives 75% of the sunlight that bathes our planet. That places it squarely in the habitable zone, where temperatures could allow liquid water to cling to its surface. But here's where it gets even more intriguing. Unlike many exoplanets around red dwarfs, which orbit so close they're tidally locked, Kepler 1649c completes a full orbit in just 19.5 Earth days. Yet its star is so cool and faint that this snug orbit still keeps it in the Goldilocks zone. Imagine a world where the sun hangs low and red in the sky, casting a perpetual twilight glow over landscapes that might hide shallow seas or misty valleys. The planet's potential doesn't stop at its size or position. Its star, Kepler 1649, is unusually quiet for a red dwarf, a rare trait in a category of stars known for violent flares that strip away atmospheres. This stability raises the chances that Kepler 1649c could have held onto an atmosphere thick enough to distribute heat and shield any oceans from freezing or evaporating. Scientists even speculate that if it has a rocky composition and active geology, like Earth's tectonic plates, it could recycle nutrients and regulate its climate, creating a stable environment for life to emerge over billions of years. Yet challenges linger. Red dwarfs, even calm ones, emit intense ultraviolet radiation early in their lives, which could have scoured the planet's atmosphere in its youth. Without a robust magnetic field, Kepler 1649c might have faced a harsh start, but life, if it exists, could have found refuge underground or in deep oceans, sheltered from the worst of the stellar tantrums. The planet's discovery also highlights an exciting truth. There might be more hidden gems lurking in old data, worlds we've already detected but haven't yet recognized for their potential. Future telescopes could tilt the odds in our favor. By analyzing the faint starlight filtering through Kepler 1649c's atmosphere, we might detect signs of water vapor, oxygen, or even methane gases that could hint at biological activity. For now, this world stands as a beacon of possibility, a reminder that sometimes the most extraordinary discoveries are hiding in plain sight, waiting for us to look again, closer this time with fresh eyes and renewed wonder. GJ667cc isn't just another exoplanet, it's a cosmic rebel, orbiting in a star system so chaotic it defies everything we thought we knew about where life could survive. Picture this, a rocky world 23 light-years away, basking in the glow of not one, not two, but three stars, a triple star system where the skies could feature multiple suns hanging in a perpetual dance of light and shadow. Yet somehow, against all odds, GJ667cc has carved out a stable orbit in the habitable zone of its primary star, GJ667c, a dim red dwarf that bathes the planet in a faint crimson glow. What makes this world so remarkable is its resilience. Most planets in multi-star systems are either flung into deep space or scorched by unpredictable stellar orbits, but GJ667cc clings to its path with gravitational tenacity. A year here lasts just 28 Earth days, but because the star is so cool, the planet receives about 90% of the sunlight Earth does, enough to keep temperatures in a range where water could flow. Models suggest its surface might be a rugged landscape of rocky plains and deep valleys, with gravity about 30% stronger than Earth's, making every step feel like wading through sand. But the real intrigue lies in the skies. The other two stars in the system, GJ667 and b, orbit much farther out, appearing in J667c, sees heavens as blindingly bright points of light, hundreds of times more luminous than our full moon. Their influence is subtle but profound, occasional gravitational nudges that could stir the planet's geology, fueling volcanoes or tectonic shifts that recycle nutrients, a potential boon for life. Scientists speculate that if J667cc has a thick enough atmosphere, it might distribute heat evenly, preventing the kind of extreme temperature swings that would turn its surface into a wasteland. Discovered in 2011, this planet wasn't just another entry in the Exoplanet catalog, it was a wake-up call. Before J667cc, astronomers assumed complex star systems were too unstable to host habitable worlds. Yet here it is, a rocky underdog holding its own in a stellar circus. The discovery forced us to expand our definition of habitable, proving that life, if it exists, might thrive in places we once dismissed as too volatile. The challenges, of course, are as dramatic as the setting. Red dwarfs like J667c are notorious for their flares, and without a magnetic field, the planet's atmosphere could be slowly eroded by stellar winds. But life, if it's there, might have found refuge underground or in deep oceans, sheltered from the cosmic chaos above. Future telescopes could analyze the chemistry of its atmosphere for signs of water or methane, clues that this world isn't just a survivor, it's a pioneer. J667cc doesn't just challenge our assumptions, it rewrites the rules. In a universe where most stars are part of multi-star systems, this planet is a beacon of possibility, proving that even in the most turbulent neighborhoods, the ingredients for life might find a way. Kepler-20 2b isn't just another exoplanet, it's a milestone, the first world we ever found orbiting comfortably in the habitable zone of a sun-like star. Discovered in 2011 by NASA Kepler mission, this distant planet 600 light-years away shattered assumptions overnight, proving that Goldilocks conditions weren't just theoretical. With a radius 2.4 times Earth's, it's a super-Earth, enveloped in an orbit that takes 290 days, eerily similar to our own year. But the real magic lies in its starlight. Kepler-20 2b's sun is a G-type star, almost a mirror image of ours, bathing the planet in just 25% less warmth than Earth receives. That delicate balance means liquid water could exist here, not frozen or boiled away, but pooling freely on the surface. Imagine standing on this world. The gravity would feel heavier, pressing down on vast, sprawling landscapes, perhaps continents veined with rivers or shallow seas stretching to the horizon. Early models suggested it could be a water world, a globe swallowed by ocean with no land in sight. But newer research hints at something even more intriguing, a mix of rock and water where tidal forces or volcanic activity might churn nutrients into the water, creating a broth ripe for life. The planet's thick atmosphere, if it has one, could act like a thermal blanket, trapping just enough heat to keep the climate stable. What made Kepler-20 2b so revolutionary wasn't just its potential, it was the timing. Before its discovery, most exoplanets we'd found were either scorching gas giants or frozen oddballs. Here, suddenly, was proof that planets like Earth could exist around stars like ours. The scientific community erupted with excitement. For the first time, we had a tangible answer to the question, could there be other Earths? Telescopes couldn't confirm an atmosphere back then, but the mere possibility rewrote mission priorities, fueling the development of instruments like the James Webb Space Telescope. Yet challenges loom. Kepler-20 2b's size puts it in a hazy category between rocky super-Earths and mini-Neptunes. Without knowing its composition, we can't say for sure if it has a solid surface or a suffocating hydrogen shroud. And its star, while sun-like, is older, meaning the planet has faced billions of years of cosmic weather, from radiation bursts to asteroid impacts. But if life did emerge here, it's had an unimaginable head start. Kepler-20 2b isn't just a candidate for alien life, it's a symbol. Its discovery marked the moment the search for habitable worlds shifted from speculation to strategic pursuit, proving that the universe might be littered with planets like ours waiting in the quiet glow of distant suns. Teegardens Star B doesn't just orbit in the habitable zone, it dances on the edge of what we thought was possible for alien life. Just 12 light-years away, this rocky world circles one of the smallest, coldest stars known to science, a dim red dwarf so faint it wasn't even discovered until 2003. Yet despite its star's meek glow, Teegardens Star B ranks among the most Earth-like exoplanets ever found, with an Earth similarity index of 0.95, a score that puts it neck and neck with our own planet for potential habitability. What makes this world so extraordinary is its delicate balancing act. A year here lasts just 4.9 Earth days, an orbit so tight it would be suicidal around a hotter star. But Teegardens Star is a cosmic ember radiating barely 8% of our sun's warmth, meaning even at this intimate distance, the planet basks in gentle Goldilocks conditions. Surface temperatures could hover around 28 degrees Celsius balmy by Earth standards, raising the tantalizing possibility of liquid water pooling in ancient riverbeds or shallow seas. The star itself is another stroke of cosmic luck. Unlike the violent tantrums of Proxima Centauri or TRAPPIST-1, Teegardens Star is a paragon of stellar serenity. Its low activity means fewer deadly flares, giving this planet a fighting chance to hold onto an atmosphere over billions of years. Without the constant bombardment of radiation, molecules like oxygen or methane might persist long enough to spark and sustain life. But standing on this world's surface would feel anything but familiar. Tidal locking ensures one hemisphere forever faces the star, a frozen tableau of perpetual daylight, while the other languishes in endless night. The terminator line between these extremes could host a narrow band of temperate twilight, where air currents might ferry warmth and moisture, creating oases of stability. Photosynthesis here would be a struggle. The star's light peaks in the infrared, painting the landscape in hues invisible to human eyes. Yet life, if it exists, might have evolved to harness these wavelengths, turning the planet's vegetation, if it has any, into a surreal, dark tapestry. The real intrigue lies in TRAPPIST-1's silence. Despite its calm demeanor, the star is ancient. At least 8 billion years old, meaning Teegardens Star B has had twice as long as Earth to cook up life's chemistry. Telescopes have yet to detect an atmosphere, but future instruments could scan for the faint fingerprints of water vapor or ozone. If found, this unassuming world would leap to the top of humanity's interstellar travel list, close enough to reach in a few decades with breakthrough propulsion, and potentially welcoming enough to step onto without a spacesuit. Teegardens Star B isn't just a scientific curiosity, it's a paradox. A planet that shouldn't exist by old models, orbiting a star too faint to notice until this century, yet ticking every box for habitability. Its discovery forces us to ask, if life can thrive in such quiet, forgotten corners of the cosmos, how many other Earths are hiding in plain sight just beyond the glow of our Sun? Kepler 438b might be one of the most Earth-like worlds we've ever discovered on paper. Orbiting a red dwarf star 470 light-years away, this exoplanet is a near-perfect match for Earth's size, clocking in at just 12% larger, with a rocky composition that suggests familiar landscapes of mountains, valleys, and possibly even oceans. Its orbit is poetry in motion, 35 Earth days long, placing it squarely in the habitable zone where temperatures could allow liquid water to pool on its surface. Picture a world where the sun hangs low and red in the sky, casting a dim, perpetual twilight over rolling plains or misty shorelines. Under that faint glow, life might have found a way to cling to existence. But there's a catch, and it's a violent one. Kepler 438b's star is a tempestuous beast, prone to eruptions so powerful they make our sun's solar flares look like firecrackers. Observations reveal these flares can be 10 times more energetic than anything recorded in our solar system, bombarding the planet with X-rays and ultraviolet radiation capable of stripping atmospheres bare. Imagine standing on the surface as the sky suddenly ignites with a searing pulse of light, the air itself ionizing around you. Even if life had begun here, these repeated stellar tantrums could have scoured the planet's surface clean, leaving behind a desolate wasteland. Yet despite these apocalyptic conditions, Kepler 438b hasn't been ruled out as a candidate for habitability. Why? Because life, as we're learning, is stubborn. Underground aquifers or deep ocean trenches could shield microbes from the radiation, much like Earth's extremophiles thrive in volcanic vents or Antarctic ice. The planet might also possess a magnetic field strong enough to deflect some of the star's deadliest particles, or an atmosphere thick enough to absorb the blows without collapsing entirely. Some models even suggest that these flares could trigger chemical reactions in the atmosphere, creating new organic molecules, raw ingredients for life, in their aftermath. The real intrigue lies in what we don't know. Telescopes haven't yet confirmed whether Kepler 438b has an atmosphere or water, but its Earth-like size and orbit make it a prime target for future studies. If it has held onto its air against the odds, this world could teach us how life perseveres in the universe's harshest neighborhoods. Kepler 438b isn't just a lesson in planetary science, it's a test of resilience, proving that even in the face of celestial fury, the right conditions might still whisper the promise of life. Ross 128b might be the most overlooked gem in our cosmic backyard, a world so close, just 11 light-years away, it's practically next door in galactic terms. Orbiting a quiet red dwarf star, this exoplanet is a study in contrasts. Smaller than Earth but packing 1.3 times our planet's mass, with gravity that would feel noticeably heavier underfoot. Yet what truly sets it apart isn't its size or distance, it's the remarkable stability of its home star. Unlike the violent tantrums of Proxima Centauri or TRAPPIST-1, Ross 128 is a stellar pacifist, emitting almost no flares or radiation bursts. That tranquility gives Ross 128b something rare among red dwarf planets, a fighting chance to hold onto an atmosphere and maybe even life for billions of years. Picture standing on this world's surface. The sky would glow a deep, dusky red, the star hanging small and dim like a fading ember. A year here lasts just 9.9 Earth days, but because Ross 128 is so cool, the planet basks in gentle habitable zone warmth. Surface temperatures could hover around -60 degrees Celsius chilly, but if the planet has a thick carbon dioxide atmosphere, greenhouse effects might push that into a range where liquid water could pool in sheltered valleys or beneath icy crusts. Scientists speculate it could resemble a colder version of early Mars, with subterranean aquifers or geothermal hotspots nurturing life away from the frigid surface. The real magic lies in the star's age, at least 5 billion years old, possibly twice that Ross 128 has had eons to calm its youthful storms, offering its planet an era of stability Earth's sun won't achieve for billions of years. That timescale is key. If life requires patience as much as chemistry, this world has had double or triple the head start Earth did to cook up complex organisms. Telescopes have already detected tantalizing hints of metals in the star's composition, suggesting the planet might be rich in the same heavy elements that fueled life on our world. But mysteries linger. Ross 128b is likely tidally locked, with one side forever day and the other eternal night. Yet atmospheric models suggest winds could ferry heat to the dark side, creating a narrow band of twilight where temperatures might be just right. Future instruments like the extremely large telescope could analyze starlight filtering through its atmosphere for biosignatures, oxygen, methane, or even industrial pollutants hinting at intelligence. For now, Ross 128b stands as a quiet rebel, proof that life's best chances might not lie in flashy, Earth-like worlds, but in the overlooked corners of the cosmos where patience and calm reign supreme. HD 85512b isn't just another super-Earth. It's a world that defies the odds, orbiting a star so stable it's practically a cosmic metronome. Located 36 light-years away in the constellation Vela, this planet is 2.5 times more massive than Earth, with gravity that would make every step feel like wading through wet sand. But what truly sets it apart is its position. Perched on the inner edge of its star's habitable zone, where temperatures could allow liquid water to exist if the planet has the right atmospheric blanket. Picture standing on its surface, the sky would glow orange, lit by the steady, dim light of HD 85512, a K-type star slightly cooler and smaller than our Sun. But don't mistake its meek glow for weakness. This star is a model of consistency, with none of the violent flares or radiation bursts that plague red dwarfs. That stability is a game-changer. While planets like Proxima Centauri b are bombarded by deadly stellar tantrums, HD 85512b has enjoyed billions of years of calm, giving it a rare chance to hold onto an atmosphere and maybe even nurture life. The planet's orbit is another stroke of cosmic luck. A year here lasts just 58 Earth days, but because the star is so cool, it doesn't scorch the surface. Instead, temperatures could average around 25 degrees Celsius, balmy by Earth standards, if the planet has a cloud cover reflecting some of the starlight. Scientists speculate it might have a thick carbon dioxide atmosphere, acting like a thermal blanket to trap heat and prevent water from freezing. But there's a tantalizing possibility. If the air contains just 35% cloud coverage, conditions could be mild enough for Earth like lakes or rivers. The real intrigue lies in what we haven't seen yet. HD 85512b's atmosphere remains a mystery, but its star's tranquility makes it a prime target for future telescopes. Instruments like the extremely large telescope could analyze starlight filtering through its air, searching for the faint signatures of water vapor, oxygen, or even methane, a gas often linked to biological activity. If detected, this world would leap to the top of the list for potential life-bearing planets. Yet challenges linger. The planet's mass suggests a rocky composition, but without plate tectonics, it might lack the geochemical cycles that regulate Earth's climate. And if its atmosphere is too thick, the surface could resemble Venus, a hellish pressure cooker where water boils away. But HD 85512b is a masterclass in cosmic potential. It proves that habitability isn't just about size or distance, it's about patience, stability, and the quiet, enduring grace of a star that knows how to keep its temper. In a universe where most stars are volatile teenagers, HD 85512 is the wise elder, offering its planet the rarest gift of all, time. And in that time, life might have found a way. Kepler 283c is the quiet contender in the search for alien life, a world that doesn't make headlines with flashy extremes, but ticks every box for habitability with understated precision. Located just over 1,700 light-years away in the constellation Lyra, this exoplanet is a near-perfect Earth twin in size, measuring just 1.8 times our planet's diameter. But its true allure lies in its orbit, a graceful 293-day journey around its star, placing it squarely in the habitable zone where liquid water could cling to its surface. Unlike the tempestuous red dwarfs that dominate exoplanet discoveries, Kepler 283c star is a K-type orange dwarf, smaller and cooler than our Sun, but remarkably stable, offering a gentle amber glow that bathes the planet in just enough warmth to avoid freezing or boiling its potential oceans. Standing on this world's surface, the sky would feel familiar yet foreign. The sun, though dimmer than ours, would cast a softer, peach-toned light over landscapes that might mirror Earth's own rolling hills, shallow seas, or even sprawling forests if life has taken root. Gravity at roughly 20% stronger than Earth's would give every step a subtle heaviness, but not enough to crush the possibility of complex ecosystems. The real magic, though, is in the star's temperament. K-type dwarfs are the Goldilocks of stellar real estate. They burn slower and live longer than Sun-like stars, with lifespans stretching up to 70 billion years, ample time for life to emerge, evolve, and perhaps even reach intelligence. Discovered by NASA Kepler telescope in 2014, Kepler 283c wasn't just another entry in the Exoplanet catalog, it was a quiet revolution. At the time, most habitable zone planets were either super-Earths or gas giants, but here was proof that Earth-sized worlds could exist in the sweet spot around stars quite different from our own. The implications were profound. If a planet this familiar could form around a K-type dwarf, the galaxy might be teeming with similar worlds, each offering a stable stage for life's chemistry to unfold. Yet challenges linger. The planet's size suggests a rocky composition, but without confirmation of an atmosphere, it's impossible to know if it has the right mix of gases to trap heat and distribute it evenly. Tidal locking could also be a factor, one side perpetually facing the star, the other locked in darkness, but atmospheric currents might ferry warmth to the night side, creating pockets of habitability in the twilight zones. Future telescopes could tilt the scales, searching for the faint fingerprints of water vapor or carbon dioxide in its air. Kepler 283c isn't just a scientific target, it's a lesson in cosmic subtlety. In a universe that often rewards the loud and dramatic, this world whispers a compelling case for patience, stability, and the quiet persistence of the right conditions. If life exists here, it wouldn't be a fluke. It would be a testament to the universe's knack for crafting perfection in the most unassuming places. Gliese 581g might be the most debated world in the search for alien life, a planet that may not even exist yet refuses to fade from scientific discussion. Discovered in 2010 orbiting the red dwarf Gliese 581 20 light-years away, this exoplanet sparked immediate controversy. Some astronomers hailed it as the first truly Earth-like world found in a habitable zone, while others argued the data was just noise, a ghost in the stellar measurements. At the heart of the debate is its delicate detection. This planet doesn't transit its star, so it wasn't spotted by the usual dip-in-light method. Instead, researchers found it by tracking subtle wobbles in the star's motion, a technique that leaves room for interpretation. If real, Gliese 581g is a heavyweight contender for habitability. Roughly 3 to 4 times Earth's mass, it likely has enough gravity to hold onto a thick atmosphere with surface conditions that could allow liquid water to pool. Its orbit lasts just 37 Earth days, but because its star is so dim, that snug distance places it squarely in the Goldilocks zone. Picture standing on its surface, the sky would glow a deep garnet, the sun hanging small and dark red like a dying ember. Tidal forces might lock one face permanently toward the star, creating a scorching day side and a frozen night side, but between them, a sliver of twilight could offer temperate conditions where water flows and life clings. The controversy only deepens when you consider the star itself. Gliese 581 is older and calmer than many red dwarfs, with fewer violent flares that could strip away atmospheres. That stability raises the stakes. If the planet exists, it's had billions of years for chemistry to brew life. Some models even suggest it could have a global ocean beneath a hydrogen-rich atmosphere, a Hycean world where microbes thrive in the crushing depths. But without direct observations, these ideas remain speculative at best, poetic at worst. What keeps Gliese 581g in the conversation isn't just the science, it's the lesson. The dispute over its existence forced astronomers to refine their methods, leading to more rigorous checks for false signals in wobble data. It also underscored how little we know about red dwarf systems, where planets often defy our expectations. Even if this world is a mirage, the hunt for it expanded our understanding of where and how to look for life, future telescopes could settle the debate, peering into the Gliese 581 system for atmospheric hints or orbital confirmations. Until then, this enigmatic world lingers as a reminder. In the search for alien life, sometimes the most compelling discoveries are the ones we're not even sure are real. Kepler 440b isn't just another exoplanet in the habitable zone. It's a study in cosmic contradictions, a world where Earth-like promise collides with stellar chaos. Located 850 light-years away in the constellation Lyra, this planet is roughly 1.6 times the size of Earth, putting it squarely in the super-Earth category. But what makes it truly remarkable is its orbit, a 301-day journey around its star, placing it right in the middle of the habitable zone, where temperatures could allow liquid water to exist. Picture standing on its surface, the sunlight would feel weaker than ours, the star, a K-type orange dwarf casting a golden, muted glow over landscapes that might mirror Earth's own, with rolling plains or shallow seas reflecting that dimmer light. Yet the real drama unfolds when you look closer at Kepler 440 itself. Unlike the steady, predictable rhythm of our Sun, this star is a variable, a celestial heartbeat that pulses with irregular brightness. Some days it might shine with relative calm, others it could flare unpredictably, bathing the planet in bursts of radiation. For a world like Kepler 440b, that variability isn't just a curiosity, it's a climate roller coaster. Models suggest these fluctuations could trigger wild temperature swings, with periods of thawing and freezing that challenge the very idea of a stable habitable zone. Imagine a planet where oceans might melt under sudden stellar surges, only to refreeze when the star dims again, creating cycles of expansion and contraction that reshape the surface over millennia. But life, if it exists here, might have found a way to adapt. Earth's own extremophiles thrive in environments just as hostile, from boiling hydrothermal vents to Antarctic ice sheets. On Kepler 440b, organisms could retreat underground during violent stellar activity, sheltering in subsurface aquifers or deep sea trenches until conditions stabilize. The planet's size also works in its favor. Its stronger gravity might help it retain a thick atmosphere, acting as a buffer against the star's mood swings. That airy envelope could distribute heat more evenly, smoothing out the worst of the temperature extremes and creating microclimates where life could cling to existence. The intrigue doesn't stop there. Kepler 440 is older than our Sun, around 6 billion years, giving its planet an unimaginable head start on the chemistry of life. If biology did emerge here, it's had eons to evolve resilience, potentially crafting survival strategies we've yet to imagine. Future telescopes might one day analyze the planet's atmosphere for signs of these adaptations, like unusual gas mixtures that hint at life's fingerprints. For now, Kepler 440b stands as a testament to the universe's creativity, proving that even in the face of stellar turbulence, the right conditions can whisper the promise of life, if you know how to listen. Kepler 1638b isn't just another exoplanet, it's a cosmic reflection of Earth, orbiting a star so similar to our Sun that standing on its surface might feel hauntingly familiar. Located roughly 3,000 light-years away in the constellation Cygnus, this world is a near twin in size, measuring just 1.2 times Earth's diameter, with gravity that would feel almost indistinguishable from home. But the real magic lies in its orbit, a 264-day journey around its star, placing it squarely in the habitable zone where temperatures could allow rivers, lakes, or even oceans to cling to its surface. Picture a landscape bathed in golden light, with a sun hanging in the sky almost indistinguishable from our own, a G-type yellow dwarf named Kepler 1638, burning with the same steady intensity as the star that fuels life on Earth. What sets this planet apart isn't just its Earth-like dimensions, but the stability of its stellar parent. Unlike the volatile red dwarfs that dominate exoplanet discoveries, Kepler 1638 mirrors our Sun's calm demeanor, offering a reliable rhythm of light and warmth. That consistency is critical. Over billions of years, this star has likely provided just enough energy to keep the planet's climate balanced, not so much that water boils away, nor so little that it freezes into a global ice sheet. Models suggest Kepler 1638b could have a rocky composition, with active geology like plate tectonics recycling nutrients and regulating atmospheric chemistry, much like Earth's own dynamic systems. Yet the planet's potential goes deeper than its orbit. Its star's age, around 6 billion years, slightly older than our Sun, means Kepler 1638b has had an extra billion years for life's chemistry to simmer. If life did emerge here, it might have reached complexity long before Earth's first microbes stirred in primordial seas. The atmosphere, if it exists, could be rich with oxygen or methane, gases often linked to biological activity. Future telescopes might even spot the faint glow of city lights or industrial signatures, though that's a stretch. It's a thrilling reminder of how closely this world mirrors our own. Challenges, of course, linger in the unknowns. Tidal locking could mean one side bakes under perpetual daylight while the other languishes in endless cold. But an atmosphere thick enough might distribute heat, creating twilight havens where life could thrive. Or perhaps it's a water world with no land at all, a global ocean hiding secrets in its depths. For now, Kepler 1638b remains a tantalizing glimpse of what's possible, proof that Earth's recipe for life, a rocky planet, a steady sun, and time, might not be unique but a repeating verse in the universe's grand chorus. Lighten B isn't just another exoplanet, it's a cosmic neighbor with a resume that demands attention. 12 light-years away, practically within shouting distance in the grand scheme of the galaxy, this rocky world orbits a small, quiet red dwarf star called Lighten Star. But don't let its modest stellar parent fool you. What Lighten B lacks in flashy size or dramatic flares, it makes up for with something far more compelling. A near-perfect scorecard for habitability. With an Earth Similarity Index of 0.9, one of the highest ever recorded, this world isn't just a candidate for alien life, it's a mirror held up to our own planet, reflecting back conditions so familiar they're almost eerie. Imagine standing on its surface. The gravity would feel nearly identical to Earth's, thanks to a mass just 3 times our planet's. The sky overhead would glow a deep, dusky red, the star hanging small and dim like a fading campfire. But despite the faint light, Lighten B basks in the Goldilocks zone, receiving just enough warmth to keep water liquid without boiling it away. A year here lasts 18 Earth days, a blink compared to our orbit, but the star's cool temperament means that tight dance doesn't scorch the surface. Instead, temperatures could hover around a brisk but livable -20 degrees Celsius, with the potential for greenhouse gases or an insulating atmosphere to push that into more temperate ranges. The real allure of Lighten B lies in its quiet resilience. Unlike the violent tantrums of Proxima Centauri or TRAPPIST-1, its host star is a model of stellar decorum, emitting almost no flares or radiation bursts. That tranquility gives this planet a rare gift: time. Over billions of years, it could have held onto an atmosphere thick enough to distribute heat, shield against cosmic rays, and maybe even nurture weather systems. Telescopes haven't yet confirmed the presence of air or water, but models suggest it could have both, perhaps deep oceans hidden beneath icy crusts or misty valleys sheltered from the chill. Then there's the tantalizing mystery of tidal locking. Like many planets orbiting red dwarfs, Lighten B likely has one face permanently turned toward its star, while the other sinks into eternal night. But that doesn't spell doom for habitability. Atmospheric currents could ferry warmth to the dark side, creating a twilight belt where temperatures are just right. Photosynthesis here would be a challenge. The star's light is mostly infrared, but life, if it exists, might have evolved to harness those wavelengths, painting the landscape in colors invisible to human eyes. For scientists, Lighten B is more than a target, it's a benchmark. Its proximity makes it one of the easiest habitable zone planets to study, a laboratory for testing theories about alien atmospheres and biosignatures. Future telescopes could analyze its air for traces of oxygen or methane, gases that might hint at biological activity. And if those signs appear, this unassuming world would leap to the top of humanity's interstellar travel list. 12 light-years is still an impossible distance with today's technology, but projects like Breakthrough Starshot aim to shrink that gap within decades. Lighten B doesn't just blur the line between science and speculation, it erases it. In a universe where most exoplanets are either scorched wastelands or frozen oddballs, this world stands as a quiet rebel, proving that Earth's recipe for life might not be unique. It's a reminder that sometimes the most extraordinary discoveries aren't found in the dazzling glow of distant stars, but in the steady, patient light of the ones right next door. Kepler 1544b isn't just another exoplanet, it's a cosmic balancing act, a world that threads the needle between familiarity and mystery. Orbiting its star 1,138 light-years away, this planet is a near-perfect Earth twin in size, measuring just 1.2 times our planet's diameter. But the real intrigue lies in its orbit, a 368-day journey around its star, a rhythm so close to Earth's own that standing on its surface might feel almost like home. Picture a landscape bathed in golden light, with seasons shifting at a pace we'd recognize as Kepler 1544. A star slightly smaller and cooler than our Sun casts a steady, amber glow over rolling plains or misty shorelines. What sets this world apart isn't just its Earth-like cadence, but its star's remarkable stability. Unlike the fiery tantrums of red dwarfs or the erratic pulses of variable stars, Kepler 1544 is a K-type orange dwarf, a stellar class known for its patience and longevity. These stars burn slower and live longer than Sun-like stars, offering their planets billions of years of predictable warmth. For life, that consistency is everything. While Earth's biosphere had to endure cosmic catastrophes and ice ages, Kepler 1544b might have enjoyed a gentler timeline, its climate undisturbed by stellar outbursts or extreme swings in temperature. The planet's potential doesn't stop at its orbit. Its size suggests a rocky composition, with gravity just enough stronger than Earth's to give footsteps a subtle heaviness, but not enough to crush the possibility of complex life. Models hint it could have active geology. Think volcanoes churning nutrients into the soil or tectonic plates recycling carbon, key ingredients for regulating a stable climate. But the million-dollar question remains, does it have an atmosphere? Telescopes haven't yet confirmed one, but the star's calm demeanor boosts the odds. Without violent flares or radiation storms, Kepler 1544b could have held onto its air for billions of years, creating a blanket thick enough to trap heat and shield the surface from cosmic rays. Imagine the possibilities. If this planet has oceans, they could be stirred by tides from a nearby moon, assuming one exists, or fed by underground reservoirs bubbling up through geothermal vents. Its skies might host weather patterns not unlike Earth's, with clouds gathering over continents and storms brewing over alien seas. Photosynthesis could evolve under that dimmer sun, painting vegetation in deep reds or purples to absorb every precious photon. Or perhaps life clings to the Terminator line, where perpetual twilight offers respite from the extremes of day and night. Kepler 1544b is more than a scientific curiosity, it's a benchmark. Its discovery proves that Earth's recipe for habitability, a rocky world, a steady star, and time, isn't unique. It's a reminder that the universe might be littered with worlds where the conditions for life align as neatly as they did here, whispering the promise that we're not alone in the cosmos. GJ273b isn't just another exoplanet, it's a cosmic paradox, a world where the promise of habitability collides with the stark realities of tidal locking, all while sitting tantalizingly close to Earth. Just 12.4 light-years away in the constellation Canis Major, this planet orbits the quiet red dwarf star GJ273, also known as Lytton Star. Discovered in 2017, GJ273b quickly became a headline grabber, not just for its proximity making it one of the closest known potentially habitable exoplanets, but for its delicate position in the habitable zone where temperatures could allow liquid water to exist. Imagine standing on this world's surface. The sky would burn a perpetual, deep crimson, the star hanging small and dim like a fading coal. A year here lasts just 18.6 Earth days, an orbit so tight it would be lethal around a hotter star. But GJ273's cool, meek glow means this snug dance places the planet squarely in the Goldilocks zone, where sunlight is just strong enough to thaw ice without boiling it away. Models suggest surface temperatures could hover around -20 degrees Celsius chilly, but with the right atmosphere, greenhouse effects might push that into a range where water could pool in sheltered valleys or beneath icy crusts. Yet GJ273b's biggest challenge isn't temperature, it's time. Like most planets orbiting red dwarfs, it's tidally locked, with one hemisphere forever scorched by daylight and the other plunged into eternal night. The boundary between these extremes, the Terminator line, could be the only place where conditions are temperate enough for life. Picture a narrow ribbon of twilight where air currents, if the planet has an atmosphere, might ferry warmth from the dayside, creating a habitable belt where water could flow and clouds might gather. But without atmospheric redistribution, the contrast between these realms could be apocalyptic. A scorching desert on one side, a frozen wasteland on the other. The star itself adds another layer of intrigue. GJ273 is older and calmer than many red dwarfs, with fewer of the violent flares that typically strip away atmospheres. That stability raises the stakes. If this planet has held onto its air, it's had billions of years for chemistry to brew life. Some astronomers even speculated could host a global ocean beneath a hydrogen-rich haze, a Haitian world where microbes thrive in the crushing depths. But the real wild card is proximity. At 12.4 light-years, GJ273b is close enough to study in unprecedented detail. Projects like METI, Messaging Extraterrestrial Intelligence, have already targeted this system with radio signals, a controversial effort to hail potential neighbors. Future telescopes could soon peer into GJ273b's atmosphere, searching for the faint fingerprints of water vapor or methane. If found, this unassuming world would leap to the top of humanity's interstellar travel list, close enough to reach within a century with breakthrough propulsion, and potentially welcoming enough to step onto without a spacesuit. GJ273b isn't just a scientific target, it's a mirror held up to our own isolation, a reminder that the universe's most promising real estate might be right next door, waiting in the quiet glow of a star too faint to see with the naked eye. Kepler 296e isn't just another Earth-sized world, it's a masterclass in cosmic ambiguity. A planet that teases the line between habitable dream and frozen enigma. Orbiting a dim, cool star over 1,200 light-years away, this exoplanet is a near-perfect match for Earth in size, measuring just 1.5 times our planet's diameter. But what truly captivates astronomers isn't its stature, it's its precarious dance on the edge of the habitable zone. Imagine standing on its surface. The sky would glow a deep, muted orange, the star Kepler 296 hanging small and faint, casting shadows so soft they barely exist. A year here lasts just 34 Earth days, yet because the star emits less than 5% of our sun's warmth, that snug orbit still places the planet in the Goldilocks zone, at least in theory. The star itself is a puzzle. Kepler 296 is a binary system with two red dwarfs locked in a gravitational embrace. The planet orbits the larger of the pair, a star so cool it's barely visible to the naked eye from Earth. Red dwarfs are notorious for their volatility, but Kepler 296 is relatively calm, a cosmic stroke of luck, as violent flares could have stripped away any atmosphere eons ago. That stability raises tantalizing questions. Could this planet have held onto an airy envelope thick enough to trap heat and distribute it across its surface? Models suggest it's possible, especially if the atmosphere is rich in greenhouse gases like carbon dioxide, creating a thermal blanket to compensate for the star's feeble glow. Discovered by NASA Kepler telescope in 2014, Kepler 296e wasn't just another entry in the exoplanet catalog, it was a revelation. Before its detection, most Earth-sized worlds we'd found were either scorched hellscapes or frozen marbles. Here, suddenly, was proof that planets like ours could exist around stars utterly unlike the Sun. The implications rippled through astronomy. If a world this familiar could thrive in such alien stellar conditions, the galaxy might be littered with hidden Earths, each adapting to the quirks of their dim, red suns. Yet the planet's habitability hinges on details we can't yet confirm. Tidal locking is almost certain one side forever day, the other endless night, but atmospheric currents could ferry warmth to the dark hemisphere, creating a twilight belt where temperatures are just right. Photosynthesis would be a struggle under that crimson sun, but life might have evolved to harness infrared light, painting hypothetical vegetation in shades of black or deep purple. Alternatively, the planet could be a snowball world, its oceans frozen solid beneath a thin atmosphere, with only geothermal vents offering liquid oases. The real intrigue lies in what we might learn next. Future telescopes could analyze starlight filtering through Kepler 296e's atmosphere, searching for the faint signatures of water vapor or methane. A detection would rewrite our understanding of where life can cling, proving even the dimmest stars can nurture worlds rich with possibility. Until then, this enigmatic planet remains a riddle, a reminder that the universe's most profound answers often lie just beyond the edge of our vision, waiting in the quiet glow of an alien sun. Captain B isn't just another exoplanet, it's a relic from the dawn of the galaxy, a world so ancient it might hold secrets older than Earth itself. Orbiting a dim red dwarf just 13 light-years away, this super-Earth is one of the oldest known planets in the Milky Way, with an estimated age of 11.5 billion years. To put that in perspective, when Captain B was already 6 billion years old, our solar system hadn't even formed yet. That staggering timeline means this planet has had more than double the time Earth has had to cook up the chemistry of life, making it a tantalizing time capsule from an era when the universe was still in its infancy. What makes Captain B especially intriguing is its position in the habitable zone, a region where temperatures could allow liquid water to exist. Despite orbiting a star far cooler and smaller than our Sun, its tight 21-day orbit keeps it bathed in just enough warmth to avoid freezing solid. Picture standing on its surface, the sky would glow a deep, rusty red, the sun hanging small and dim like a dying ember. Gravity here would feel crushing, roughly 5 times stronger than Earth's, pressing down on vast mountain ranges or perhaps global oceans trapped beneath thick ice caps. But beneath that weight, something remarkable might be hiding. The star itself, Captain's star, adds another layer of cosmic drama. Unlike most stars that circle the galactic center in orderly paths, this one is a rebel, a hypervelocity star hurled from the wreckage of an ancient dwarf galaxy devoured by the Milky Way billions of years ago. Its chaotic journey means Captain B has endured a history of extreme environments, from dense star clusters to the violent outskirts of merging galaxies. Yet against all odds, it's clung to its orbit, a testament to the resilience of planetary systems. The real question is whether life could have survived such a turbulent past. Red dwarfs like Captain's star are notorious for violent flares in their youth, which might have scoured the planet's early atmosphere. but if Captain B held onto even a fraction of its air, the payoff could be extraordinary. Over billions of years, geothermal heat or tidal forces from a possible moon might have kept subsurface oceans liquid, providing a refuge for extremophiles. Some scientists even speculate that its ancient age means any life here could be vastly more advanced than Earth's, with biology refined over epochs we can barely comprehend. Yet mysteries linger. Tidal locking likely forces one side of the planet into perpetual daylight and the other into endless night, but atmospheric currents could create a twilight belt where temperatures are just right. Future telescopes might analyze starlight filtering through its atmosphere for biosignatures, oxygen, methane, or even industrial pollutants hinting at long-lost civilizations. For now, Captain B stands as a ghost from the cosmos's violent youth, a world that's watched galaxies collide and stars ignite, all while quietly holding onto the possibility that life, against all odds, found a way. Kepler-60 2e isn't just another exoplanet, it's a cosmic mirage, a world that blurs the line between fantasy and reality. Located roughly 1,200 light-years away in the constellation Lyra, this distant planet orbits a star eerily similar to our Sun, basking in the same golden glow that fuels life on Earth. But what truly sets it apart is its staggering potential as a water world. With a diameter 1.6 times Earth's, Kepler-60 2e straddles the boundary between rocky super-Earth and oceanic paradise, a planet where continents might be rare luxuries and the horizon stretches uninterrupted beneath endless skies of swirling mist. Its orbit is poetry in motion, 122 Earth days of graceful revolution around its star, Kepler-60 2, a Sun-like G-type dwarf that offers something rare among habitable zone hosts: stability. Unlike the violent tantrums of red dwarfs, this star burns with quiet consistency, granting its planets billions of years of uninterrupted climate. For a world like Kepler-60 2e, that tranquility could mean the difference between a fleeting oasis and an enduring cradle for life. Surface temperatures likely hover around 0 degrees Celsius, but with the right atmospheric blanket, thick with greenhouse gases like carbon dioxide or methane, this planet could transform into a balmy, globe-spanning aquarium, its oceans warmed by trapped starlight and churned by tides from unseen moons. The real magic lies in its classification as a water world, a term scientists use for planets where oceans dominate the surface. Imagine standing on a lone rocky outcrop, the only land for thousands of miles, watching waves the size of mountains roll under an orange-hued sky. Beneath those waves, pressures would be crushing, creating layers of exotic ice forms, not the fragile crystals we know, but dense, hot ice that behaves like molten rock. Yet even in those abyssal depths, life might find a way. Earth's extremophiles thrive near hydrothermal vents, where chemistry replaces sunlight as the engine of biology. On Kepler-60 2e, entire ecosystems could pulse around volcanic seams on the ocean floor, their existence hidden beneath miles of swirling currents. Astrobiologists rank this world among the most promising targets for alien life, and for good reason. Water is only part of the equation, its star's age is the other. At 7 billion years old, Kepler-60 2 has had 3 billion more years than our Sun to nurture its planets. If life emerged here, it's had epochs to evolve beyond microbes, perhaps even reaching intelligence. The planet's potential atmosphere adds another layer of intrigue. Telescopes haven't yet confirmed its composition, but if it harbors oxygen or methane, these could be fingerprints of biological activity. Future missions like the Habitable Worlds Observatory aim to peer into such atmospheres, searching for the faint spectral signatures of alien biochemistry. Yet challenges loom. Without direct observations, we can't rule out a more exotic reality, a steam world, where the oceans have boiled into a thick, soupy atmosphere, or a frozen shell hiding subsurface seas. Tidal locking could also skew the climate, with one side scorched by eternal daylight and the other locked in ice. But if currents distribute heat efficiently, even these extremes might host temperate twilight zones where life clings to equilibrium. Kepler-60 2e isn't just a scientific curiosity, it's a mirror held up to our own planet's future. As Earth's oceans rise with climate change, this world offers a glimpse of what a truly aquatic Earth might look like. It forces us to ask, is life's destiny tied to land, or can it flourish in the universe's boundless seas? Every unanswered question about this distant world underscores a humbling truth. We're only beginning to fathom the diversity of habitats the cosmos has to offer. GJ1214b isn't just another exoplanet, it's a cosmic riddle wrapped in a thick, steamy shroud. Located just 40 light-years away in the constellation Ophiuchus, this enigmatic world defies easy categorization, straddling the line between gaseous mini-Neptune and something far more intriguing, a water-rich super-Earth. Discovered in 2009, GJ1214b quickly became a puzzle for astronomers. With a mass 6.5 times Earth's and a diameter 2.7 times larger, it's too hefty to be a rocky planet like ours, yet too small and dense to match the ice giants of our solar system. Instead, it occupies a murky middle ground, a mini-Neptune with secrets lurking beneath its opaque, hydrogen-rich atmosphere. What makes this planet so captivating is the swirling debate about what lies beneath those dense clouds. Early observations revealed an atmosphere so thick it blocks nearly all light from penetrating to the surface, creating a permanent planet-wide twilight. But the real mystery lies in its composition. Some models suggest GJ1214b could be a water world, with a global ocean thousands of miles deep, trapped beneath a crushing atmosphere of hydrogen and helium. Picture an abyss where the pressure is so intense that water exists not as liquid or ice, but as exotic superfluid states or even a bizarre, electrically conductive form known as ionic water. In this alien realm, the very laws of physics twist into unfamiliar shapes, creating conditions unlike anything in our solar system. Yet not all scientists are convinced. Alternative theories propose that GJ1214b might be a gas dwarf, a planet with a rocky core smothered under an atmosphere so thick it mimics the gassy envelopes of Neptune or Uranus. The truth might lie somewhere in between, a hybrid world with a sloshing mantle of water mixed with ammonia or methane, topped by an atmosphere dense enough to crush a submarine. What's undeniable is the planet's extreme nature. Surface temperatures likely soar above 200 degrees Celsius, hot enough to melt lead, while the atmospheric pressure could be hundreds of times greater than Earth's, turning air into a searing, supercritical fluid. The intrigue doesn't stop at its composition. GJ1214b's proximity to Earth makes it a prime laboratory for testing hypotheses about planetary formation and evolution. Its star, a dim red dwarf, is remarkably quiet compared to its volatile siblings, offering a stable environment for this strange world to evolve. Telescopes like Hubble and the upcoming James Webb have already probed its atmosphere, searching for chemical fingerprints that might reveal the presence of water vapor, methane, or even more exotic compounds. Each new observation peels back another layer of the mystery, forcing us to reconsider where and how life might arise in the cosmos. GJ1214b challenges every assumption we've made about habitability. It's a world where the very idea of surface might be meaningless, where oceans could blend seamlessly into sky, and where life, if it exists, would need to thrive in conditions we can barely simulate. This planet doesn't just expand the definition of an exoplanet, it shatters it, reminding us that the universe's creativity knows no bounds. Whether it's a steamy water world or a gaseous chimera, GJ1214b stands as a testament to the wild diversity of planets waiting to be understood and the thrilling uncertainty that keeps astronomers searching the skies. From scorching super-Earths to icy ocean worlds, we've explored 30 extraordinary exoplanets that redefine what habitable means in the cosmic sense. Each one tells a different story. Kepler 186f proved Earth-sized worlds could exist in habitable zones, while GJ 1214b challenged our very definitions of planets with its steamy, shrouded mysteries. We've seen worlds bathed in eternal twilight like Tigodon star B, chaotic triple-star systems like GJ 667cc, and ancient relics like Captain B that have witnessed nearly the entire history of our galaxy. Some, like Kepler 442b, mirror Earth so closely they feel like parallel versions of home, while others like K218b introduce entirely new categories of planets we never imagined could exist. This incredible diversity isn't just a catalogue of distant worlds, it's a testament to how far exoplanet science has come in just 3 decades. Remember, the first confirmed exoplanet discovery only occurred in 1992. Since then, we've progressed from detecting bloated gas giants to analyzing the atmospheric composition of Earth-sized worlds light years away. Instruments like the James Webb Space Telescope are now teasing out the chemical fingerprints of water vapor, methane, and potential biosignatures, while upcoming missions like the Habitable Worlds Observatory promise to directly image exoplanets in unprecedented detail. What makes this era truly thrilling is how every new discovery shatters old assumptions. Planets can thrive around pulsars in binary systems or orbiting stars completely unlike our Sun. Life, if it exists out there, might not need Earth-like conditions at all. It could be thriving in the crushing depths of Hycean worlds, beneath icy shells, or even in the turbulent skies of gas giants. The search for alien life is entering its most promising chapter yet. Within our lifetime, we may finally answer the ancient question, are we alone? Upcoming breakthroughs could range from detecting microbial signatures in exoplanet atmospheres to picking up signals from intelligent civilizations. Projects like Breakthrough Starshot aim to send tiny probes to nearby systems like Proxima Centauri, while initiatives like SETI continue listening for cosmic whispers. Stay curious because the next decade will rewrite textbooks. Every week brings new discoveries, planets with metallic clouds, rogue worlds drifting between stars, or perhaps the first definitive evidence of life beyond Earth. The universe has shown us it's far more creative than we ever imagined, and these 30 worlds are just the beginning. Press that notification bell because when the big discovery comes, and it will, you'll want to be there when humanity takes its next great leap into understanding our place in the cosmos.